Tonight, look up at the sky. You will see stars. You will think you understand what you are looking at, but you don't. Not even close. Your brain is one of the most powerful pattern recognition machines ever built by evolution. It can read a face in a crowd of thousands. It can catch a ball moving 40 miles an hour. It can learn a language before it can even walk. And yet, when it comes to the actual size of space, your brain simply breaks down. It was never built for this. It was built for something much smaller, much slower, and much closer to home. Here's the strange part. You can say the numbers out loud. You can write them on a whiteboard. You can even do the math correctly on a test. But somewhere between the number and your imagination, something fails. You say billion the same way you say hundred. Your brain treats them as cousins. They are not cousins. They are not even in the same universe of scale. And that gap between the number you can say and the size you can actually feel is the real subject of tonight's video. Start small. Start with your own body. Your ancestors evolved to judge distance across a savanna, not across a galaxy. They needed to know if a lion was close enough to kill them, or far enough to ignore. They needed to know if the next waterhole was a morning's walk or a day's walk. Every tool your brain has for distance was built for ranges you could cross on foot in a lifetime, using your own two legs. Nothing in that toolkit prepares you for a light year. So what is a light year, really? It is the distance light travels in 1 year, moving at roughly 670 million miles per hour. Light could circle the Earth 7 times in a single second. And yet, to cross just 1 light year, it needs an entire year of non-stop travel. Your brain hears that and nods. It sounds impressive. But does it feel impressive? Not yet. Not really. Try this instead. Imagine the sun as a basketball. In this model, Earth is a grain of sand, orbiting about 30 yards away. Neptune, the outermost planet, is nearly 2 miles from that basketball. Already your mental map of the solar system, that neat little diagram from your childhood textbook, all the planets lined up close together, is wrong. Badly wrong. And here is the part that breaks people every single time. On the same scale, the next nearest star to our sun would be over 4,000 miles away. 4,000 miles, on a scale where Neptune is only 2 miles out. The solar system is not crowded. It is almost entirely empty space, with a few grains of sand scattered across a vast, dark ocean. Astronomer Carl Sagan spent much of his career trying to solve exactly this problem, the problem of scale blindness. He argued that the human imagination did not evolve to grasp cosmic distances, and that without deliberate tools like scale models and analogies, people would always underestimate the universe by staggering, almost comic margins. He wasn't being poetic. He was being precise. Because when researchers have actually tested this, the results are almost embarrassing. In studies on numerical cognition, psychologist Stanislas Dehaene found that human number sense is intuitively logarithmic, not linear. What does that mean in plain English? It means your brain naturally feels the difference between 1 and 10 as much bigger than the difference between 1 billion and 10 billion, even though mathematically, both gaps represent the exact same multiplication. Your gut, left to its own devices, compresses huge numbers together. 1,000,000, 1,000,000,000, 1,000,000,000,000. To your intuition, they start to blur into one vague category: a lot. But a lot is doing an enormous amount of hiding. Here's a way to feel it instead of just hearing it. 1,000,000 seconds is about 11 and a half days. 1,000,000,000 seconds is about 31 years. Say those two numbers out loud again. Million, billion. They sound almost identical. 11 days, 31 years. That is the actual gap your brain is failing to register every time it hears those words back to back. Now scale that failure up to the size of the observable universe, and things get almost absurd. The Milky Way, our home galaxy, contains somewhere between 100 billion and 400 billion stars. Not planets, not moons, stars. Full-size suns, many larger than our own. And the Milky Way is just one galaxy among an estimated 2 trillion galaxies in the observable universe, according to a 2016 study led by astrophysicist Christopher Consulis. 2 trillion, each one packed with hundreds of billions of stars of its own. Try to actually picture that, not the number. The number is easy to type out. The picture. Can you hold 2 trillion of anything in your mind at once? You can't. Nobody can. Not because you are somehow deficient, but because the architecture of human imagination simply was not designed to render quantities past a certain threshold. Somewhere around a few thousand, your brain quietly gives up on picturing individual units and switches to a fuzzy blob labeled many. This is why space documentaries lean so heavily on comparison. If the sun were the size of a beach ball, if you shrank the galaxy down to the size of a dinner plate, these aren't just cute tricks for television. They are cognitive necessities. Without them, the numbers simply pass through your mind without leaving a mark. The same way a sentence in a language you don't speak passes through your ears without meaning. There is something almost humbling in this. For all of human history, people have looked up and felt small, but most of them, for most of that history, had no real concept of how small. The ancient astronomers who mapped constellations believed the stars were fixed points on a sphere, not far-flung suns separated by unimaginable gulfs of emptiness. It wasn't until the 19th century that astronomer Friedrich Bessel first measured stellar parallax accurately enough to calculate the true distance to a star beyond our solar system. And even then, the number he arrived at was so large that many of his contemporaries struggled to accept it. So, what does your brain actually do when faced with a number it cannot picture? It substitutes. It quietly swaps the real quantity for something smaller and more manageable without telling you it happened. This is why people can hear that a star is 4 light years away and feel almost the same reaction as hearing it is 400 light years away. The word light years is doing so much of the work that the actual number barely registers. 400. Your gut shrugs at both. And this isn't just about space. This same mental shortcut shapes how you understand a national debt in the trillions, or a pandemic that kills hundreds of thousands, or a forest that burns across 1 million acres. Your brain reaches for the nearest emotionally graspable version of the number and quietly discards the rest. Space just happens to be the purest, most extreme example of this glitch, because nothing in daily life prepares you for numbers this large. Here's the twist, though. Feeling small in the face of all this isn't actually a failure of your brain. It's proof that it's working exactly as designed. A mind built for the size of space, instead of the size of a savanna, would have been useless to your ancestors. It would not have caught the lion in time. It would not have found the waterhole before dark. The very same limitation that makes the universe impossible to truly picture is the limitation that kept your ancestors alive long enough to have descendants who could someday build telescopes and stare into the dark, wondering what's really out there. So, the next time you're standing outside looking up and someone tells you that the light from a distant star left its source before humans had invented writing, don't worry if you can't quite feel the true weight of that fact. Nobody can, not really, not intuitively, not fully. What you can do is notice the gap. Notice the moment your imagination quietly gives up and reaches for a lot instead of the real number. That noticing, that small flicker of humility in front of something too big to hold, is the closest any human mind has ever come to actually touching the size of the universe. Tonight, look up at the sky again. You will still see stars, but now you know. You were never really seeing them. You were only seeing the small, familiar shadow your brain drew in their place.